Hello everyone who watched this video, especially our lecture. So we are from group 5 from machine learning that we're gonna present it about supervised learning on Titanic dataset. As you can see, we here from we're gonna introduce ourselves first. As you can see at the first, Paulina Pereira de Carvalho, and the second me, Karen Hillary Sinaga, and the third Naufal Fahmi, and the fourth Rizvan Anuri, and the last is Billy Farid Rachman. Next, please. So in this slide, I will explain the objective of our machine learning project. For the first, our main goal is to predict the survival of passenger aboard the Titanic using supervised machine learning models. So this means we're using historical data where the outcomes are already known to train our model and make accurate prediction. And secondly, we focus on analyzing the data using two specific model, like logistic regression or random forest. This model will help us understand which factors must influence survival and allow us to build a reliable prediction system. And the next slide it will be presented by Paulina.
Thank you so much, Caroline, for the opportunity. So in this slide, we're going to talk about the data overview. So for this project, we selected the Titanic dataset available from Kaggle, which is commonly used for introductory machine learning tasks. And the dataset center around the historical event of the Titanic shipwreck in 1912 and contains detailed information about passengers aboard the ship. Specifically here, the dataset includes 891 rows and 12 columns. Each rows represent a unique passenger, and the columns contains features such as passenger route, a unique identifier for each passenger, P class, which is the ticket class from first, second, or third class, name, it's like the full name of the passenger, sex, gender of the passenger, age in years, he receives SP, which number of siblings or spouses aboard the Titanic, part, which number of parents or children aboard, ticket, its ticket number, fare, it's the amount paid for the ticket, cabin, and embark or port of embarkation. And there are three ports, which C, Q, and S. This data set is ideal for classification tasks because our goal is to predict a binary outcome, whether a passenger survived or not based on the given feature. So in the next slide, we'll explain how we handled missing data and prepare the data set for analysis. Next slide, please. After understanding the dataset structure, we move on to the data cleaning phase to prepare the data for analysis and model building. First, we notice that each column has several missing values, not only age, but there is also cabin and embark. So since age is a numerical feature and can affect survival probability, for example, children might have been prioritized, we choose to fill these missing values with the median age. So we use the median rather than the mean to reduce the influence of outliers. And next, we handled the embark column, which had two missing values. As you can see in the picture there, embark is like two missing values. So since this column is categorical and the most frequent port of embarkation was S for the Southampton, as I mentioned before, we filled the missing entries using the mode. And as for the cabin column, however, had too many missing values. More than 75% of the entries were empty. Because of this, we decided it was best to drop the entire column rather than trying to input or guess values, which could introduce noise. So lastly, we remove columns that were not useful for prediction. These include like passenger, Gerald name, and ticket. While they help identify passengers, they don't contribute directly to the survival outcome and may add unnecessary complexity to the model. model. So with this data set cleaned, we were ready to explore the data more deeply, which we'll show you in the next slide. Next slide, please.
Okay, so this slide will be explained by me. So we move on to exploratory data analysis. So in this graph, we can conclude that we analyzed the data and found the women had higher survival rates than men, and passengers in first class, which is here, had better chance of survival. So next slide. Supervised learning approach. So we use the classification models to predict the target variable survived, and we apply logistic regression and random forest classifier. We have data split with 80% training and 20% testing. Models trained on selected features are sex, piece classes, age, fare, embark, SIP, and parse. So as we can see in this data right here. Okay, next slide.
Now let's look at our model evaluation result. We assess our model using accuracy as our primary metric, with the dataset divided by 80 by 20 for training and testing purposes. As you can see, we compared two models. Logistic regression achieved 78.21% accuracy, while random forest performed better with 81.59%, 56% accuracy. The confusion matrix on the left illustrates why random forest is superior. It is more accurately identified both survivors and non-survivors in our dataset. The feature importance chart on the right shows which variable had the greatest impact on the model's decisions. Based on this result, we recommend implementing the random forest model as it provides more reliable prediction for this particular task. Next slide, please.
Moving on to our future importance analysis of the random forest model, this chart highlights which feature have the strongest impact on predicting survival outcomes. As illustrated, gender stand out as the top factor, showing that it plays like a key role, consistent with the likely enforcement of the Women and Children First protocol. Following that, far and age appears as major indicators, suggesting that both financial status and age group significantly affect survival probabilities. Moving to our team interpretation, we clean the data by revealing missing values, like using the median for age and mode for embark, which help the model perform better. For EDA, survival clearly depend on gender and class. Women and first-class passengers and first-class passenger had higher survival rates. We use a random forest model since it handles complex data well. Evaluation with the confusion matrix and accuracy show decent result. So precision and recall would give more insight. The most important features were sex and P-class, which match the pattern seen in the data.
So, in conclusion, supervised learning models like random forest can effectively predict Titanic survivors. We found that gender and class played the most significant roles. This project improved our skills in data processing, ADA, and machine learning. So I think that's all from us presentation. Thank you for watch and listen our presentation.